Hello and welcome back to this lecture. In this lecture, we are going to be discussing about generator expression. So we have discussed about what a generator function is in few sections back. So I would like to quickly refresh your memory on how a generator function works and how to create a generator function. So let's quickly do that. So def, then I'll write generator function. So basically, the definition of a generator function is any function that has the yield keyword, the yield statement within its body. So we have this generator function that I have created, and I want it to return odd numbers basically. So to do this, we now need to create a for loop. So for n in range 1 and 15, so I want it to return I'll need to write the condition if n modulo 2 equals not equals 0, then this is an odd number basically. So I want it to yield this odd number, just like the return statement. The yield keyword would return a value, so this should return this n, which is the odd number in this case. So now let's see what we have when we call this generator function. So when we call this generator function, let's check out what happens. So basically nothing happens from our terminal, but behind the scene some operation has been carried out. So let's see what happens when we print this generator function. So when we use the return statement, we also need to print the function call so as to see what was returned from that function. So it is the same with the generator function. You need to use the print function so you can get to see what was yielded. So the difference between a normal function, a regular function, and a generator function is that instead of the return statement or the return keyword, we use the yield keyword, which yields a value at a time. So when we run this now, we should see something. So we have a generator object. So this generator function is now a generator object. So when we print this function call, we have a generator object. So to actually get to see what we have two ways we could have gone about that. So let's create a odd number. So this odd number is going to be a list basically. So this list is now going to convert this generator function, which is like a generator object under the hood, to a list object. So when we print this odd number, so we should now have odd numbers between, so I want it to be 1 and 16, so we can have 15 included. So 15 can be included within this list that we have. So when we run this again, we should now have, okay, we have an error. This is coming from the fact that I did not call this generator function. So when we do this now, we should have what we expected. We have 1, 3, 5, 7, 9, 11, and so on. So you can see that we have been able to use this list function to basically get the list that we need. But this is not what we want actually. I am just showing you that we could have done this basically. So this generator function, the major thing is that generator function does not take up space. So it just saves a variable at a time. When you have a list will take up the space of saving. So let me just uncomment this list so that you can understand what I'm saying. So let me copy this and bring it down. So let me put it here. So at this point in time, this list is consuming memory. So it is consuming memory in the sense that it has about 10 items within it. So each item consumes or uses up a certain amount of memory. So it is using about whatever space a variable is using, an item within this list is consuming. So it consumes 10 times that space because it is saving 10 items. But in the case of the generator function, it only consumes space for just one item. So that's the major difference between using a generator function and using a list. So at this point in time, all the space that this entire generator function is consuming is compared to just one space that this one list item is consuming. So now let's call this generator function and save it into a variable. So let's do something like this: odd numbers. So this would be like the name of this would be the variable name holding the whatever value is returned from this generator function call. So now we are calling this generator function and we are assigning it to this odd numbers variable. So now we have saved this return value to this odd numbers variable. You know that at each so now we now use the next function. The next function is a function available in the global scope. It is a Python built-in function. So when I call the print function, this I'm using the print function here so that we can see our output in our terminal. So I'll use the next function on this odd numbers variable. So let's clear up our terminal and run this. So we have 1 at this point in time. So when I call this print multiple times, whereby I call the next method multiple times like this, so we would keep having items within our generator function. So at this point in time, can you see we have 1, 3, 5, 7, and 9. So by using the next function, do you understand? So this generator function yields a value each time we call the next function on it. So it basically returns each value saved into it, unlike in the case of a list whereby all the values are saved into a memory location, so it consumes a particular amount of memory. But in this case, this value would get yielded only when the next function is called. That way it does not consume memory and it only starts to use memory when the next function is called. So we'll be discussing about the generator expression. So generator expression is just like list comprehension and dictionary comprehension. It's an easier way of creating generators without having to create a function like this. So we will just do all of it in one line, just like we have done with list comprehension and dictionary comprehension. So let's see how that goes. So as we all know, we should first comment out this. So once we comment this out, then the syntax, so I'll be doing the exact same thing basically, but the syntax for creating a generator function is we are going to use a square bracket, just like we want to create a tuple, a Python tuple. But in this case, we are not creating a tuple. We have seen how to write list comprehension and dictionary comprehension. This is no different. This is exactly the same thing, but it is just that this is a generator expression. So this is referred to as a generator expression now. So what we want to do here is we want to create odd numbers just like we have done in this case. So what we do is we will now write n for n in range 1 and 16 if, then we just copy this condition, n modulo 2 not equals to 0. So as simple as that. So when we run this again, we should have the same output. So do you see we have exact same output 1, 3, 5, 7. So this is what we refer to as a generator expression. Let me add a comment there. Generator expression. So that is that. So this is a generator expression. The only difference between a generator expression and a list comprehension is just that this would be covered in brackets like this parenthesis, while in the case of list comprehension it is a square bracket. So it is quite different. So this would now return a generator object, and when we even use the print function on this variable name odd numbers, you see that we have a generator object. So do you see we have generator object gen expression at. So this is pointing to line 39. Do you understand? So this is that print odd number. So this is a generator object actually. So we are now using the next function on the object. So this is that it's as simple as that. So I hope with this lecture you now understand how you can write your generator expression. See you in the next lecture.